Hello, this is Moses Wan, and welcome to part 9 of my MATLAB tutorial series. In this tutorial, I'm going to show you a bit about linear regression. So firstly, what is linear regression? Linear regression is the process of fitting a line to a bunch of data. So as we see up here, I've got all these x values and all these y values. So when I plot them on a graph, it'll look like this. So as you can see, all these dots are all over the place, but it's kind of following a line. So what we want to do in linear regression is basically find this line of best fits, which best approximates this bunch of data. So how do we do this? Remember that linear equation from high school, y equals mx plus c? We are going to use a similar form. Y equals AO plus A1x. So AO is basically just how much this graph is moved up or down, and A1 is our gradient. So it just so happens that some nerdy mathematician came up with this formula, which surprisingly works. So n is the number of data we've got, so how many dots on the graph we've got. So basically what this is telling us is the number of data times the sum of the product of the x and y values minus the sum of the x value times the sum of the y values over the number of values we've gotten times the sum of all the x values squared minus the sum of all the x values all squared. So this will give us our gradient essentially. And to find our AO is just the mean of all the y values minus A1 times the mean of all the x values. If you want to know more about how this formula works, it's best to Google it yourself under linear regression. So let's start by programming this in MATLAB. What we want to do is program this linear regression formula into a function. So basically when we've got a bunch of data, we can just use this anytime we want. So let's start by having a function represented by this black box. We want our inputs to be all the x values and all the y values. And we want the outputs to be AO and A1. So basically what we want to do in this is firstly find n. And what is n? And that is basically number of values we've gotten inside inside this data, so number of data points. And then after that, what we want to do is sub all the values into the A1 equation, because if we do not know A1, we can't find AO. So only then can we find AO. So basically we just plunk all these formulas in, and yeah, just watch it work. As usual, I've made an earlier copy in MATLAB. So with this, we've basically defined n as how many data points, so just length of this, because this will x will come in as a big matrix, and it'll just find how many elements are in that matrix, which will equal the number of data points we have. So next, I've just got our formula in there. So the number of data times the sum of x and y, all individually multiplied element by element, minus sum of all the x's times the sum of all the y's, divided by, I should really put these in brackets because of this minus sign, otherwise it'll just evaluate this expression first, divided by the number of values multiplied by the sum of all the x values squared minus the sum of all the x values all squared. So this is how we get our A1, and our AO is basically the mean of y minus A1 times the mean of x. So yeah, as you can see, it's quite simple. It's just a 3-line code. So let's try put this in action and try put the best line to our graph we've gotten. So since I'm lazy, I'll just do a bit of copy pasting. So x equals, well, all that jazz. Y equals all that jazz. And we want to sub these into the formula. So as you can see in our linear regression formula, I've got the output of A and A1. So we need to respectively save that in its variables that we want. Linear regression, X and Y. Let's plug this into a formula. Let's say okay, so as you can see, I've wrote an M file which has got my X data and my Y data, and I've substituted in our linear regression function that we just made. That will output AO and A1 to us, and we want to make another bunch of X values, so our model line is smooth, and we want our Y model as well. So as you can see, I've just substitute AO and A1 in its respective places, and I've dot multiplied by X model, which is basically our linear equation, and I've just plotted it. So I've plotted these values, and I've made sure they're marked as X's. I've plotted X model against Y model. So this is what it looks like in the end. So as you can see, yep, it's the line of best fit. So that's how you do linear regression. I hope this tutorial helps, and yeah, if you want to know anything else, just contact me. And it's nice to hear feedback, so yeah, thank you.